Today I'm going to show you how to factorize quadratic expressions. So just to recall, a quadratic expression is an expression in the form ax squared plus bx plus c. Notice that a is the coefficient for x squared, b is the coefficient for x, and c is the constant term. Note that all a, b, and c are constants. And in particular, today I'm going to show you how to factorize monic quadratics. In other words, we have our a to be equal to 1, or in other words, the leading coefficient of this quadratic is equal to 1. So first, let me just demonstrate an example. Consider the expression x squared plus 9x plus 20. Well, note that if you want to factorize a quadratic expression, you need to express them as a product of two linear expressions. We can assume that this is expressible as x plus blank times x plus blank. Notice that our blanks here are unknown constants. And then we need to find what these constants are. So here's the trick. These constants are actually very special because they must satisfy the property that the sum of these must be equal to the coefficient of x, in this case 9, and then the product of these two must be equal to the constant term of this quadratic, which will be equal to 20. So think of two numbers that when you take the sum of both is equal to 9, and then when you take the product of both is equal to 20. I'll give you a moment. The answers to these two equations are actually 4 and 5 because 4 plus 5 is 9 and 4 times 5 is equal to 20. So if we have found our numbers, we can just plug those into our linear expressions. So we have x plus 4 times x plus 5. Let's do another example. Consider the quadratic expression x squared plus 6x plus 9. Well, we can suppose that this can be expressed as a product of two linear terms, so of x plus blank times x plus blank. And then by our previous criteria, we must have these two numbers when added together must be equal to the coefficient of x, or 6, and then when these two numbers are multiplied, they must result in 9. So instead of me giving you a moment to determine these numbers, I want to give you a trick. Sometimes the numbers that you are trying to find are very nice, and what I mean by nice is that they are either integers or rational numbers. I'm going to split 9 into some factor pairs right here. So 9 can be expressed as 1 times 9 or 3 times 3, or we can also suppose negative factors. We have negative 1 times 9 and then negative 3 times negative 3. We can just plug in these factor pairs into our first equation to see if one of these factor pairs, when summed up, gives a result of 6. Well, indeed there is, and it is 3 and 3. Because notice that 3 plus 3 is 6 and 3 times 3 is 9. So our numbers are 3 and 3 respectively. So we can combine these two together to get x plus 3 quantity squared. Sometimes these linear factors are not nice, and what I mean by that is that the constants are irrational numbers. So here's an example of a quadratic expression that has irrational factors. So we have x squared plus 7x plus 2. So we can suppose that this is expressible as a product of two linear factors. So we have x plus blank times x plus blank. By our previous criteria, we must have these two numbers when added up together gives us 7, and when multiplied together gives us 2. So we can do the trick mentioned in the previous question. So I'm going to split 2 into factor pairs. So we can have 1 times 2 or negative 1 times negative 2. And the truth is, none of these pairs of numbers will not result in 7 when added up together. So we say that this quadratic expression is not factorable with rational coefficients. So let me talk about the pros and cons about this technique. Well, the pros is that most of the time this trick is very useful for factoring some quadratic equations with relatively small coefficients as shown right here. When you split the constant term into factor pairs, you only need to cover a few cases, which is less of a hassle. And some of the cons is that when you have a relatively big constant term, you might have a hassle on trying to find the factor pairs of it. And also you might find a case where the expression is either not factorable or it It is factorable, however, it can only be done using irrational coefficients.